So to sort of round out our last bit of market design, we're going to talk about the economics of information systems. And actually, so there is a field called the economics of information. It's sort of it bridges over and overlaps sort of with a few other fields of economics. Market design is one of those, and you'll sort of see how this is relevant to everything Stephanie was just talking about. Industrial organization is a field of economics that looks at how markets are structured. So things like monopoly power versus oligopolies versus pure competition. When you see these different things, how do the characteristics of the good being supplied have an impact on that, et cetera, and so forth. And of course, also contract theory, which we discussed on Monday. And in particular, we talked about these two inefficiencies that contract theory focuses on. One is moral hazard. The other one is asymmetric information. So you might think that the economics of information is important there. But actually, both of these components come in when we're thinking about the design of information systems. So for the remaining time today, I will, in a few moments, be presenting a sort of simple model, the way that I did on Monday, and that's going to focus on this asymmetric information component only. And then after we go through that model, we can discuss a little bit more the implications on hidden actions and moral hazard, and how that plays into the design of these kinds of systems. So why is economics of information important for you? As we sort of discussed for the past hour plus, lots of blockchain teams are trying to create marketplaces, and the functioning of marketplaces depends very much on the information systems that are provided to their users. So individual choice improves with better information because we're reducing uncertainty, because we're reducing the chances that we make mistakes, and all of that can lead to better social outcomes. What we're talking about, welfare economics, because we can increase participation in markets if we have better information. We can create better matching if we have better information, and we can reduce wasteful influence activities. So it turns out that this has an impact not just on marketplaces that we're building, but it will be very important in the design and governance systems. And today we're going to focus only on the market piece, but tomorrow, when we come back for our last session, we'll talk more about the governance piece. Okay, ready to jump in. So, you may or may not have heard of this guy, George Akerlof, and his very, very famous paper called The Market for Lemons. Incidentally, Akerlof is married to Janet Yellen, but he also has many other professional accomplishments, like his Nobel Prize. So this is a really simple but super important paper in, I think, all three of these fields of economics that I mentioned earlier. Again, going to go through some pretty simple math. So this paper focuses on the example, like the marriage example we saw earlier. The example that is looked at in the paper is the market for used cars. But again, it will help us to work through the model to think about used cars as the example, but don't get too hung up on that idea. So we're going to start with, okay, there's a variety of sellers in this market. They have cars that differ in the quality, and Q is going to be distributed uniformly on 0 to 1. Okay, so we have sellers here. Sellers have utility. Yes times Q plus money. So this is a parameter that allows us to convert quality into money. And then we just add the quality that we get to the money that we get. Similarly, okay, so So a few things. So we're going to assume that this TS is the same for all of the sellers. The way that the sellers differ is by the quality of car that they have. And we're going to be able to see right away that, actually, you know what, I'm first going to show you the buyers, and then I'm going to do all the math over there. This will be a reference. Okay, so buyers have also a utility function, and it's basically the same, only we have a different parameter, which might make sense because these guys are maybe not requiring their transportation as much anymore, and these guys need more transportation, something like that. Okay, so importantly here is the quality of the car is only observed by the guy who currently owns it. So I'm a buyer, I'm going to be looking at these two cars, trying to decide which one to buy, and to me they look exactly the same, which means that I'm going to be willing to pay the exact same amount for them, regardless of the actual quality, which is something that I can't observe. That's the big asymmetric information component. Okay, so sellers are going to be willing to sell if really easy. If the amount of money that I'm going to get for selling my car is going to be bigger than the value, the total value that I have for the car. And similarly, buyers are willing to buy B times Q is greater than such B. Okay, so in particular, there's a gain from trade. We can, if we match a buyer and seller, everyone will be better off as long as TB is greater than TS. Then we have gains from trade. Okay. Oh, one thing I did want to point out, unlike the models that the model that we looked at on Monday, both of these guys are risk neutral. Great. So the next thing that what we're going to do here basically is we're going to calculate the supply and demand curves and find the price at which they intersect. Okay, so this pens. I think someone took the pens here, opened them up, and left them all day yesterday. It was all working well on Monday. Okay. That's much better. All right. Okay, so supply is going to be a function of the market price. And we're going to have two scenarios. So we sell the car, all right, so each individual, right, remember we're uniformly distributed. We're uniformly distributed, that's an arrow, important to remember, which means that if T is smaller than P, then every one of these guys, even the guy with the highest quality, is going to be willing to sell. So, oh, I'm sorry, I missed one thing. There are NS sellers and NV buyers. That's important. Okay. So the total quantity of supply will be NS if P is larger than TS, and it will be NS over T. So this tells us also the fraction of sellers who are going to sell. We know that if for sellers who are above the threshold, those are the ones who are not going to sell. The rest of them will, so this gives us the total quantity. So we would also, yes? Only in terms of telling us where the cutoff is. So that allows us to determine, because we are going to be interested to know the average quality of cars that are going to be available on this market, which we'll be able to calculate. So if our price is greater than our TS, then everyone's going to participate, and so the average quality is going to be 1/2. If P is less than TS, then the sellers at the top end of the market, the ones with the highest quality, are going to stay out because this is not going to be satisfied. So the average quality is going to go down, and this is what the function is going to be. Thank you.
Substitute here, it should do P over 2TS.
Thank you. The notes that I'm working from use capital T and small t, which I found very confusing. So I tried to translate them. Please tell me if I missed some more of those. Okay, so that is supply. Here is demand. It's simpler. Okay, so if the price is above the utility we get from the average quality, none of us are going to buy. And if the price is below the utility we get from the average quality, then all of us are going to buy. Very simple. Or all of us are going to want to buy, assuming that there's actual car available. Okay? What's QA? The average quality.
Okay.
Yeah. Okay, so what we have left is a couple of illustrations of the supply and demand curves. They look kind of funny. Oh, sorry, I forgot one part of the notes here. There's one final part of curve, and then I can draw the. Okay, so for an equilibrium, we need ST to equal V of P. And we're going to have two cases, and I'm sort of just going to tell you what the cutoff is and then prove it's a cutoff. Okay, so so our cutoff is that it's for TV to be less than 2TS. Okay, so if this is true, then P times 1 is greater than P over TV 2TS. Yes? And this equals this comes from right here. Okay? So if this is true, then we have no trade. We have this condition. Okay? So if we have to have that TB, that the value I get from quality as a buyer, is larger than TS in order to get any trade.
in order to get gains from trading, right? But if TB is less than 2 times the value to the seller, TS, then we still get no trade because the market unravels because all of the buyers think that these cars are nasty pieces of junk that they don't want anything to do with. Okay? So on the other hand, if this is not true, then we end up with the buyers willing to buy, and we're in this other case. And so I can erase over here. We have 2 working colors. It's actually more appropriate. That's your supply curve in case 1 where we have no trade. And this is the demand curve. Case. All right. Okay, so I'm going to talk through the implications of this model, but please throw your hands up if you have questions at any point in time. Okay. Again, it's a pretty simple model. The keys here are that the sellers know their quality, so they're going to be willing to stay out of the market if they value what they have too much, if they think that the car is too good. That can create a problem for the other side of the market that can't actually observe how good these cars are, and can cause them to refrain from joining the market if the average quality can't be kept up enough. Okay, so some important results that just asymmetric information, only not being able to tell what's going on in the other side of the market while they do know, that can cause the market to unravel. Even though we have gains from trading, we should all be trading with each other, right? This isn't an inefficiency. Asymmetric information is creating an efficiency, particularly if we're in a situation where no trade is happening. That is Pareto dominated by us being able to trade with each other. Now, I think perhaps this is maybe a slightly more interesting scenario, particularly for those of you who are thinking about designing a marketplace. So it's true that this is Pareto efficient, right? So every buyer that exists in this market is buying something. And each of them only wants one car, so we can't have more trades occur. We could reallocate which cars are being sold, and in fact, because the because we have gains from trade and because the buyers value higher quality cars more, we would have a higher total surplus, higher sum of utility across all players if we reallocated this demand from the low quality cars to the high quality cars. That would be an improvement on total surplus. But then the low quality sellers are going to be worse off. So we have to ask ourselves a question. Which of those outcomes is the one that we want? Do we want to foster a marketplace where high quality cars are sold and users get more utility out of participating in this market? Or do we want to leave it alone and let it devolve so that only low quality items are sold? Or perhaps even worse, the market unravels altogether.
Does that assume you're making the same amount of money in either situation? In other words, if you're not trying to simply maximize profit, you're trying to create a particular type of market, or is your first?
This is actually assuming no profitability on the part of the marketplace itself.
Okay.
This is just saying, how are these peers
Right.
going to trade with each other? And can we provide them with infrastructure to be able to achieve good trade? So interestingly, ACRA law provides some suggestions for ways that this might be fixed and ways that he thinks it is fixed in existing markets. So guarantees are one way. You can let the buyer buy the car, drive it around. If they figure out that it's actually not a good car, they can bring it back. Brand names, which he didn't say its reputation, but I do. Licenses or some sort of credential would be another way. So, for example, if we could come in and we could say, I looked at the car, I checked it, it meets this minimum threshold. I'm telling you that the minimum quality of a car that passes my standard is Q hat. Then that might get us to shift from the lowest quality cars being sold to higher quality cars being sold. Okay? So I think a thing that's very important for anyone who is designing a blockchain marketplace to understand is that there is no such thing as no design. There's no such thing as not having your fingerprints on this market. There isn't, I'm going to leave it up to the market participants and they're just going to figure it out themselves. Whether you provide the infrastructure or you don't provide the infrastructure, you are choosing what the outcome of this market is going to be. So you need to figure out, what kind of outcomes do I want? Do I want outcomes where I've given freedom to everyone and they can sell snake oil, and actually, as it turns out, no one wants to buy snake oil, and oops, I spent all these couple years developing a platform that no one's going to use? Is it important to me that low-quality sellers are enabled to dominate this market? Or do I want to provide the kind of infrastructure and information in order to allow the buyers and sellers, the peers in this market, to achieve the best outcomes for them? And that might mean picking winners and losers. But there's going to be winners and losers anyway. Okay, so that's the piece just about asymmetric information. I do want to talk a little bit about the role of moral hazard. Are there questions about this? Yes.
This is going to be very, I don't know how to frame this. Is there a way to design a system in a context where winners and losers don't exist? All are winning, but maybe at different time frames, or maybe they're sharing these assets and things like that.
So I'm going to answer. I'm going to answer in the context of this model, and then maybe we can talk about like a few different things. So for example, if the number of buyers here was larger than the number of sellers, then everyone who has a car to sell is going to sell the car. As long as we can avoid this, right? But if there's not enough buyers to go around, if there's not enough demand, then we're going to have winners and losers in this market on the seller side. But similarly, then, and this particular model doesn't account for this, but because in this model, all the buyers are the same. But if demand did exceed supply, then you have the reverse problem where you have some buyers are going to miss out just because there is not enough cars to go around, and so you're going to have to figure out who's actually going to get the cars. And right, if you're doing it by auction, then it's going to be the people who have the most money to pay. If you do it by some other mechanism, then maybe you lottery off the available cars. So I think it's a tough question, but it has to do with a mismatch of supply and demand in the market.
That's part of the Pareto dominance, is that correct? That you were talking about earlier?
So that's just saying that like we are unable to trade because, meaning no one in the market is able to trade. We have all of these sellers who want to sell their car, all these buyers who want to buy their car. We know that each trade we can facilitate creates value, but they aren't trading because of the asymmetric information. So that scenario is absolutely Pareto dominated. But so these are in this particular model, these are the only two scenarios. In the second scenario, all buyers buy. So yeah.
So can I, just to answer your question about fairness, so you do see a lot of these issues around public school assignment market design. And so there what you see is it going to be fair ex ante? So they'll, not everyone is going to get the same outcome afterwards. Only some people get to go to Stuyvesant and other ones don't. But we say, before we start, let's institute lotteries or something like that so that in expectation, we're all given a fair shot. And then maybe in realization, you can't have everyone go to the same school, right? So that's one way to think about fairness in market design.
Can you give examples of the difference between high-quality sellers? There's kind of a question about, you're saying it sort of devolves because of the asymmetric information. So what is by high-quality sellers? Do you mean sellers who provide that information, or are you talking about
so this is the quality of the car. This is the quality of the car.
Right, but now the quality of the car also changes with price. So it's difficult to provide a high-quality car at a low price.
So,
right?
and that's why some of these sellers stay out of the market.
That's right. So if you want a market that provides relevant information to everybody, including high and low quality, but some people just can't afford high quality, and they're willing to pay for the lower quality, and it's fair. So how does that factor?
So again, the issue in this model is that while the cars do have differences in quality, the buyers cannot tell the difference between any two cars. So I'm going to be willing to pay the same amount no matter which car you put in front of me because the same amount are all the same. So this is not a case where we have Mercedes and we have Hondas, right? That's, George said maybe that will help us fix this, right? But again, I agree. It's a very simplistic model, but it helps us get at one of the issues, so then we can start to unpack and see what else we need to add in order to address the specific context, the specific market that we're trying to build. So this is asymmetric information. There are a few types of asymmetric information models that we should look at. So one is what we call screening, and this would just be, let's provide some information to be able to distinguish between high-end cars and low-end cars. So the cars are how they are. Selection are a set of models where the different types reveal themselves by choosing different options. So frequently selection models are look sort of the reverse of this kind of model. So two-part pricing, or not two-part pricing, second-degree price discrimination is a version of this. So for example, airlines sell business class tickets and they sell economy tickets. And people with a high willingness to pay select themselves into business class, and people with a low willingness to pay select themselves into economy. And the airlines design everything about that. They design what the price differences are, but they also design how uncomfortable is economy compared to business class, right? So they choose what this menu looks like in order to get the buyers to reveal the type. And then the final set of models are signaling models, where different types can incur cost in order to send information to the other side of the market about their quality. So education is a big example of this. Spending a lot of time in school, getting a college degree, for example, is a costly endeavor that sends a signal to the job market about how smart or talented you are. And there are other examples of that in product markets, etc. So these are three different ways we might think about structuring information. Context matters a lot. So there's different places in the economy and different markets where these three types of models might apply differently. But you're always going to be constrained by the behavior of the people participating in this market.